Okay, so the curve C has this equation. We're going to show that dy dx is this fraction here. So the first thing you look for is a product. You can see there's a product here. Now I know we've taken away, there's a minus in front of it, but what I would do is just write it as 9x squared y. Okay, just look at the positive aspect of it first, and we'll deal with that minus later. So u will be 9x squared, v will equal to y. Okay, so that means then u dash will be 18x, and v dash, well, y becomes 1 times dy dx. Okay, and then the product rule then, well, v du dx, so 18x y plus u dv dx, so 9x squared dy dx. Okay, so differentiating this then implicitly, so you get 6y to the power 5, and you bring the 6 down. Don't forget to put dy dx on the end. Take away. This then becomes, we'll bring the 4 down, so you get 12x cubed. Now we've already differentiated the product and got this, but now we've got to take it away, yeah? So it's taking all of this away, so the minus applies throughout. So minus 18xy minus 9x squared dy dx. Okay, plus 48, well 48 is a constant, so that just becomes 0, so you get equals to 0. Okay, and we're sort of homing in on this now. What you might notice is that the values are slightly different. So you've got 6y to the power 5 here, where the answer is 2y to the power 5. So we've got to look then and see if there's anything we can cancel down. And you'll notice it's a common factor of 3. So we could divide by 3. Okay, so simplifying that, divide that by 3, you get 2. So 2y to the power 5. Divide that by 3, you get 4. Divide that by 3, you get 6. Divide that by 3, you get 3. Group then the dy dx terms together, or factorise. So you get 2y to the power 5 minus 3x squared. And take the other terms over the other side. So minus 6xy becomes plus 6xy, minus 4x cubed becomes plus 4x cubed. And finally then, because you're timesing these together, take the bracket over and divide. By 2y to the power 5 minus 3x squared. Okay, so there is your dy dx. Now in B, it says find the gradient of the tangent to C at each of the points where the curve, where C crosses the x-axis. Okay, now this bit is important here where it says it crosses the x-axis. You've got to ask yourself, what do we know is true when it crosses the x-axis? Quite simply, when any curve crosses the x-axis, well, we don't know what the x value is, but we certainly know that the y value is equal to 0, yeah? Okay. Okay, it doesn't matter where it is on the axis, the y value will be 0. And of course we know what y is, but we don't know what the x value is. And we need to know the x value in order to determine the gradient, in order to work out dy dx. It's good knowing the y value, but we do need to know these x values, don't we? Okay, so what is the x value when y is 0? Well, what's good again is we've got the equation of the curve given to us. Okay, and we can work with that. Okay, and of course when y is 0, okay, well this just becomes 0. We don't know what x is. Y becomes 0 here, plus 48 equals 0. So what you'll find is then this will just disappear, this will vanish because it's times in by 0, that's gone. Okay, and then we could take that over, so you have 48 equals 3x to the power 4. We could then divide by 3, divide through by 3, so we get 16 is x to the power 4. So then to get x, you just have to do the 4th root. Okay, because it's x to the power 4. Take the power over, you do the 4th root. But what you must remember with the 4th root, just like square root, plus or minus, right? When it's an even root, you've got to put plus or minus in front of it. Okay, and that comes out to be 2. Okay, so plus or minus 2 rather. So it crosses x-axis at 2, 0 and minus 2, 0. So then what we've got to do then is work out what the gradient is at those particular points. So we've got to work out what dy dx is. So at 2, 0, dy dx, well, if we sub it in, we will get, sub it into this here. So you simply get on the top, well, you put 0 there, that will disappear, won't it? So you get 4 times 2 cubed. On the bottom, that will disappear. So 0 there, and you get minus 3 times 2 squared. And if you work that out, that comes to be minus 8 thirds. Similarly then, at minus 2, 0, dy dx, well, if you do the same calculation, if you put it in, you'll have 4 times minus 2 cubed over minus 3 times minus 2 squared. That works out to be positive 8 thirds. Okay, so those are the values there of the gradients at those 2 points where it crosses the x-axis, minus 8 thirds and plus 8 thirds.